Four corners. Turn it down. Susan Blackaby. Turn it down. Listen. Do you hear something? There's a good chance that the answer is yes. Sound is all around us. In fact, in many places, complete quiet can be hard to find. Many of the sounds we hear around us are unwanted sounds, or noise. In urban areas, noise comes mostly from traffic, construction, and people. Noise in rural areas can come from farm equipment, passing trains, and low-flying planes. Both rural areas, left, and cities, below, experience noise pollution. The problem is that many people do not realize that noise can have serious negative effects. Of course, noise can be irritating. More than that, excessive noise, called noise pollution, harms the environment, just as rubbish and chemicals do. Loud or prolonged noise can damage your hearing and even threaten your health. In this book, you can find out more about the negative effects of excessive noise and about the precautions you can take to guard against its dangers. You will see that protecting yourself from too much noise is a sound decision. The volume control of a personal stereo is often turned up to a dangerous level. Sound versus noise. No one would argue against the importance of sound. Sound helps you to understand the world around you. Some sounds, such as speech, allow you to communicate with others. Other sounds, such as car horns and alarms, are useful as warnings. Even more sounds, such as music, entertain you and help you to relax. Yet speech, alarms, and music are sometimes considered to be noise. Sound becomes noise when it is unwelcome or unwanted. In fact, the word noise comes from the Latin word nausea, which means seasickness. What people consider noise is usually determined by time, place, and the mood of the listener. For example, everyday speech is a useful, helpful sound that people depend on in order to communicate. However, in a setting where it bothers others, such as a theater or a library, everyday speech becomes noise. Are these sounds or noises? It depends on your point of view. Just as not all sound can be considered as noise, not all noise can be considered harmful. Although most people would agree that the screech of chalk, or worse yet, fingernails on a blackboard is an unwanted sound, the noise itself is not going to hurt you. Usually, noise is harmful only if it is loud. The louder a noise, the more likely it is to damage your hearing or health or affect the environment negatively. That is why, when people talk about noise in the environment, they are usually referring to loud noise. Some irritating noises, such as the squeaking of chalk on a blackboard, are harmless. Others, such as the pounding of a jackhammer, can be harmful. How loud is too loud? The louder a noise, the more likely it is to damage your hearing. At what point does a noise become too loud? To answer that question, it's important to know a little about how sound works. Sound waves. Sound is produced when an object vibrates or moves back and forth very quickly. This movement also makes the air around the object vibrate. The air transmits the vibrations in the form of sound waves. Most of the sounds that people hear travel in the same way that ripples spread out from a pebble thrown into a pond. Sound waves spread from the source of a noise like ripples in water. How sound waves are created. Think of how a guitar string vibrates when plucked. The vibration causes air molecules around the string to move. These molecules hit nearby molecules, and those molecules hit molecules near them. The molecules become compressed, or squeezed together. As the vibrating string moves back, it leaves space into which the molecules can spread, separating them again from nearby molecules, which in turn separate from molecules next to them, and so on. The combination of compressing and separating of molecules creates a sound wave that travels away from the vibrating string. Air molecules vibrate to produce sound when a guitar string is plucked. Sound waves, although invisible, can be compared to ocean waves. The highest point of the wave is called the crest. The lowest point is called the trough. Half of the height of a sound wave, the distance between the crest and the trough, is called its amplitude. The amplitude determines the intensity, or loudness, of a sound. The size of a wave's amplitude depends on the degree to which the molecules are being compressed by the vibration. As a rule, the more bunched up the molecules are when they are being compressed, the more energy a sound wave contains and the higher its amplitude. When the molecules are not as compressed, the sound wave has a smaller amplitude and carries less energy. When you amplify a sound, you make it louder. On some kinds of electronic equipment, the user controls the amount of sound amplification. Sound waves, energy and loudness. Different sounds have differently shaped waves. This sound contains a small amount of energy. It has a low amplitude and produces a soft sound. This sound contains a large amount of energy. It has a high amplitude and produces a loud sound. Measuring loudness. Units called decibels, dB, are used to measure the amplitude, or loudness, of a sound. A soft whisper measures 30 dB, a conversation measures about 60 dB. A prolonged sound of 80 dB is loud enough to cause pain or even damage to the ear. Surprisingly, quite a few familiar sounds are louder than 80 dB. For example, the movements of a large truck or train and the noise from construction sites all exceed this level, as can listening to music through stereo headphones. In fact, sound coming through the headphones of the average personal stereo set at medium volume can reach levels of more than 90 dB. The decibel scale. dB, example. 0, softest sound a human can hear. 30, low whispering. 40, quiet bank, living room. 50, refrigerator, distant traffic. 60, talking, nearby air conditioner. 70, noisy cafeteria, heavy traffic. 80, nearby alarm clock, city traffic. 90, blender, lawn mower, truck traffic. 100, music heard on headphones, chainsaw. 120, loud thunderclap, music heard near speakers at a rock concert. 140, aeroplane, gunshot. 180, rocket launch. Rocket launches are among the loudest sounds humans have ever produced. Reflection and absorption. Another way to determine how damaging a loud noise might be is to simply look around a room or an area. Sound waves can be reflected or absorbed as they travel out from their source. An echo is an example of sound reflection. It is caused by sound waves bouncing off a hard surface. Sound reflection makes it possible for you to hear your own voice come back when you yell, "Hello," in a big empty room. Think about how noisy a cafeteria can be. The hard plastic furniture, plastic trays, linoleum floor and smooth walls are all surfaces that reflect sound. On the other hand, soft materials